All right, law of sines, law of cosines practice. You guys have a test next Wednesday over chapter 5. A small amount is going to be from 5.1, 5.2, 5.3, which we will go over tomorrow and next week. A majority is going to come from sections 5.5 and 5.6 because law of sines and law of cosines is a lot. There's a lot of information. There's lots of things to do. We're going to have, other than law of sines and cosines, you'll have area and stuff like that. So I wanted to have like a little refresher where we pulled everything together and you guys had that to reference. Tomorrow in class, you're going to work with probably partners on a classwork assignment that's due at the end of the class period, but just practicing this. Then I'm going to give you your review over the weekend that you're welcome to start working on, but we're going to work on it Monday and Tuesday in class. It's kind of lengthy, but it's really good practice to get you ready for your test. But you guys have to have your calculators. You have to know how to use them. You have to know when to use them, that sort of a thing. So let's go through and let's just talk about each of these different scenarios. Like I said, every day that we've done this, you will be given the formulas on the test. You will also be given the directions that say, using the law of sines, blah, 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 blah. All right, there's different scenarios when you're given law of sines questions, law of cosines questions. You're going to be given the formulas, and in the directions, it will also say, using the law of sines, solve the triangle. When they tell you to solve, guys, that means you have to find all the stuff missing. You have to determine what you need to find. So in a case like number 1, all right, we're going to do 3 law of sines problems, 2 law of cosines, and 1 Heron's. But it's important that you understand with what you're given, what you could possibly find. When you have law of sines, what do we have to consider? There could be 2 triangles. There also could be what? No triangle, right? So it could be 0, 1, or 2. You always have to assume, when you're talking about law of sines, that there could be 2 triangles. In the event that they give you 2 angles to begin with, do you see how in this problem they gave us 2 of the 3 angles? Yes or no? Yes. Okay, if you see that they give you 2 of the 3 angles, there can only be 1 triangle present. That's the only situation where it will be only 1 if 2 angles are given. So in this first question, we don't have any letters, so I'm going to go ahead and just assign some letters here. What am I missing? What am I looking for here?
Angle B.
I'm looking for angle B. Okay, so I have to find angle B. What else do I have to find? I have to find side A, so little a, and little b. All right, we're going to round everything to the nearest whole number. On your test, the directions will be different. It'll say, round to the nearest 10th, 2 decimal places, whatever. But today we're just going to round everything to the nearest whole number. It's just easier. So in this case, actually for this first one, let's do to the 10th because they already have 2 decimal places, right? How would I find angle B? I'm going to add 46.5 plus 39.4. And what do I get? 85.9. All right, and then I say 180 minus that, correct? What's 180 minus 85.9? 94.1. So angle B is 94.1 degrees. Now that I know that angle B is 94.1 degrees, I have solved everything inside my triangle. Now I have to solve the outside. Well, what do you guys notice? Do I have a side length and its corresponding angle measure? Yes or no? Yes, I have C. I have all the information I need about C. I have sine of C, so sine of 39.4 over 7 equals, what do you guys want to find? Okay, sine of B over side B. Do we know what side B is? I'm sorry, I should put the angle measure there. 94.1, and I don't know what B is, so that's what we're finding. So we cross multiply 7 times the sine of 94.1 equals B times the sine of 39.4. Divide both sides by sine of 39.4. 39.4. And B equals about how much? So B is about 11 units, whatever they are telling you in your problem. Here they don't give us any, so we can just say 11. Now we can do the exact same thing. I'm going to use the same proportion. My sine 39.4 over 7 equals the sine of what? 46.5 over A, because we don't know what that is. So we're going to cross multiply. 7 times the sine, 46.5, equals A times the sine of 39.4, right? Divide by sine of 39.4. And let's see what we get. A is about how much? So 7 times the sine of 46.5 divided by sine of 39.4. And I get 7.99996. So about 8. So B is about 8 units long. And we have solved our triangle. How many triangles did we find? There's one. The reason there's only one is because they gave us 2 angles. There's no possibility of a second triangle when they give us 2 of the angles, okay? So moving along to the next one. Yes, sir. Question was, how do you know for sure? Well, they gave us 2, so we assume that that's in both. So the one that we found was 94, right? So if I find the supplement of that, 180 minus, if you do 180 minus 94.1, you get 85.9, right? When I add that number plus the other 2 angles, what should it equal? 180. And when you do it, it equals 171.8. So when they give you 2 angles, there is no possibility for a second triangle, ever. There's only one. It's when they only give you 1 angle is when we have to look at this, in a situation like this. Do you see a triangle? No. So go ahead and draw one real quick. You can label it the same way every time, A, B, and C. A is 76 degrees. Across from A is 18. Across from B is 20. So I am given 1 angle. I have to assume, I don't know for sure, I'm going to find out, but I have to assume there could be how many triangles? 2. So right away I'm going to get my problem set up and I'm going to say, all right, there might be 2. And I'm going to say that, well, in each triangle, angle A is 76 degrees. So angle A in each triangle, 76 degrees. It's saying use law of sines. Let's figure out what we're missing. We're missing angle B. We're missing angle C, right? So I got to find angle B. I got to find angle C. They'd be in both triangles if there was one. And I'm missing side C, right? So if it says use law of sines, that means I should already have the information to use law of sines. Do I? Do I have an angle measure and its corresponding side length? Yes. Yeah. So I can say sine of 76 over 18 equals, what do you want to find? B or C? Doesn't matter. B. Okay, let's find B. Why did I say it doesn't matter? Okay, so if you look at either one, say somebody said, oh, I want to find C. Could you find C?
Yeah.
No, because you don't have an angle measure or a side length. So you got to go with what you have. But if you said, oh, yeah, I'm going to do C, you would write sine C over C and then realize, oh, wait, I don't have enough information. So let's cross multiply. 18 times the sine of B equals 20 times the sine of 76. Divide both sides by 18. And I get the sine of B equals what? So I have 20 times the sine of 76. Practice this in your calculator. Divided by 18. I get 1.0781. Is that the answer I'm looking for? No. This is where we have to hit second sine in our calculator. I get the inverse. So second sine, second answer. And what does your calculator say? Error. What is that telling you? There's no triangle. You can cross this out and say, no triangle. Somebody last period is like, that's it? That's it. Once you determine, oh, wait a second, with the information they gave me, I can't even form 1 triangle, let alone 2. That's what you have to show me. Yes, sir. All right, let's move down to this one. Again, it says to use what? Law of sines, okay? So we know, oh, okay, we're going to use the law of sines. Guys, if you're using the law of sines, what's the possibility? Possibility is 2 triangles. When is there a possibility of 2 triangles? If you have 1 angle given. Good. So triangle 1, triangle 2. Let's figure this out. So let's label what we have. I have that angle A is 20.5 degrees, right? I have 0.5 in my degree, so let's have at least 1 decimal place in all of our answers. I see that side A is 12, so across from A is 12, and side B, the side across from B, is 31. So what are the pieces that I'm missing? Angle B, angle C, and side C. Okay, so let's just write that down. This is what I have to find. I have to find angle B, I have to find angle C, and I have to find side C in both triangles if there is a triangle, if there is a second triangle. What is given to me at the beginning? A is 20.5. So I'm going to say, all right, in both triangles, if there is two, A is 20.5 degrees. All right. So do I have enough information to use the law of sines?
No.
I do. I have a side length, right, 12, and the corresponding angle. So I can say, okay, well, the sine of 20.5 over 12 equals, what angle do you want to find? We got to find B. How come we have to find B? Because I have nothing about C. I don't have side or an angle, but I do have side B. So we're going to cross multiply. We get 12 times the sine of B equals 31 times the sine of 20.5. Divide both sides by 12. And I get the sine of B equals 31 sine 31 times the sine of 20.5 divided by 12. And we get 0.9047. That's not what I want, though. I want sine -1. I want the inverse sine. I want to know what angle B is. So I hit second sine, second answer. And I get 64.78. So I say 64.8 degrees. All right. Here is where we find out if there's a second triangle or not. 64.8 degrees. The first angle you find is what you use as your finding point, right? I find the supplement of this. Supplement means 180 minus 64.8 gives me what? What's 180 minus 64.8? 115.2. So 115.2 degrees. Now, I'm not for sure that I have a second triangle. I'm just saying, if I did, that would be the second angle measure. So let's finish solving the angles in triangle 1. When I add 20.5 and 64.8, I get 85.3. Agreed? Yeah. So how do I figure out what angle C is in triangle 1?
Wait, how'd you do it?
180 minus. I added A and B. So 180 minus 84.5, I get 94.7 degrees. Everybody agree? Okay, now let's see if triangle 2 exists. I'm going to add 20.5 and 115.2, and I get 135.7. Is that less than 180? Yeah. So can I say 180 minus and get a positive answer?
Yeah.
Yep. 180 minus 135.7, and I get 44.3. So do two triangles exist in this scenario? Yes. Yes, sir. All right, Joseph just asked a great question. The left-hand side, we added A and B. It was 85.3. That's less than 180. So you say 180 minus, you get angle C. Same thing on the right-hand side in triangle 2. We added A and B. The sum was less than 180, so you know, oh, wait, there's enough degree measurement left over to have a third angle.
It cannot be negative?
No.
No.
So if you added A and B and you got 200, is there a second triangle possible? No, you just cross that part out. So now you're going to find side C in both triangles because they're going to be different lengths. Go back to your original law of sines. We used sine 20.5 over 12. That's in both triangles. So I'm going to say sine 20.5 over 12 equals, in the first triangle, we found that angle C was 94.7 over little c. In the second triangle, use the exact same proportion because angle A and side A are in both triangles. And in this case, I'd say sine of 44.3 over little c. And then we just cross multiply. So 12 times the sine of 94.7 equals C times sine 20.5. Divide by sine 20.5. What does C equal? So I have 12 times the sine of 94.7 divided by sine of 20.5. Do you see, Paulo, that we're dividing by both signs?
Yeah.
We're finding a side length. So I come out with 34.15. That's not like where you would hit second sine because we're finding the side measure. We're not finding, it didn't say sine of C, it just says C. So I get 34.2-ish. About 34.2, okay. And then over here, same thing. We're going to cross multiply. So 12 times the sine of 44.3 equals C times the sine of 20.5 divided by sine of 20.5 divided by sine 20.5. And here I get C is about, so 12 times the sine of 44.3 divided by sine 20.5. What'd you guys get? Okay, I got 23.9. Now, that problem is a tad bit time consuming, yes? I can't give you 10 of these and then give you 10 other questions, right? You'll probably have 1 or 2 law of sines. Possibly have second triangle, possibly not. You just have to make sure that you always assume that there is and check. Everybody got that?
Yeah.
Okay.
We're doing.
All right, so let's move on then to law of cosines. I'm going to do 2 of these. I'm going to do 11, and I'll also do 23. Because 9 and 11 are the exact same scenario, just different numbers. And 20 and 23 are the exact same scenario, just different numbers. So I look here and I say, it's going to tell you, using the law of cosines, right? We have our law of cosines here. We're good to go. Do I have a picture to refer to?
No.
So what should I do? Well, let's draw one, okay? Again, we're going to name our angles are with capital letters. Our sides are with lowercase. So across from angle B is side B, which is 5. Across from angle C, which is side C, is 3. And across from A, I don't know what that is, correct? What angle measures do I know? I know that angle A is 102 degrees. Do I know what angle B is? No. Do I know what angle C is? So let's talk about the stuff that we're trying to find. Okay, so we have to find 3 things. We have to find angle B, angle C, and side A. So I'm going to write down what we need to find. Angle A, angle B, and side C. Now, even if it didn't say using the law of cosines, could you use the law of sines here?
Yes.
Do you have an angle measure and its corresponding side? No. So we have to find that, we have to create, we'll say, that angle measure corresponding side. So what should I find first? A. I'm going to find A. Now, guys, your law of cosines is right there. I already know it, so I'm going to write it in. I have A squared equals, so we have A squared equals 3 squared plus 5 squared, or you could write 5 squared plus 3 squared, doesn't matter, minus 2 times, I have 3 and 5, times the cosine of what angle are we talking about? 102. Remember, whatever side you're looking for, the angle's on the end, or vice versa. So guys, at this point right here, you can put that whole thing in your calculator. Go ahead and do that. Everybody do that. Pablo, question.
Oh yeah. What if you didn't have, like, what if you had all this time?
We're going to do that example in 1 second.
But you do the same thing, right?
Same formula, yeah. But we're going to look for the angle. So I'm going to say 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 102. You guys get 40.237, something like that. So 40.23735. Now, I wrote a lot of decimal places out because if I rounded that to 40 and then I took the square root, your answer, the more you round within your problem, the further and further away your answer gets from the most accurate answer. So I would give yourself at least 4 or 5 decimal places at this point. So now I'm going to take the square root of both sides, and I get A equals, what's the square root of that? You can hit second x squared, second answer. 6.34. So we'll round it to a whole number. We'll just say A is about 6. You can. Let's look at the directions. What do the directions say? Nearest degree, right? Then the nearest what? 10th? Okay. So you want to, what do you guys want to round to? Nearest 10th? Okay, so it'd be 6.3. Okay. So A is 6.3. We have to find B and C. I don't know why I wrote A there. So now that I know that A is 6.3, do I have enough information to now use the law of sines?
Yes.
Yes. I can say now, all right, well, the sine of 102 over 6.3 equals, what do you guys want to find, B or C? B. The sine of B over, how long is side B? 5. So we would cross multiply 5 times the sine of 102 equals 6.3 times the sine of B, right? Divide by 6.3. And I get that the sine of B is, what's 5 times sine of 102 divided by 6.3. 0.7763, something like that. But is that what I want? I think that's, yeah. Is that what I want? No. I want the inverse of that. So I want second sine, second answer. And I get that angle B is about 50.9 degrees, right? It says the directions say to round to the nearest degree. So you would say angle B is about 60 degrees. So B is about 60 degrees. Now, if I know angle A and I know angle B, how can I find C? You add and subtract. 102 plus 60 equals 162. And then what's 180 minus 162?
18.
So angle C is 18 degrees. Now, at this point, you guys can look at this, and some of you are like, how do I check my answer? Well, you can kind of check here by saying, all right, the longest side should be across from the biggest angle. Correct? The shortest side should be across from the shortest angle. Is that the case? What's the smallest angle? 18? What's the smallest side? 3? Good. What's the biggest angle? 102? What's the biggest side? A is 6.3. All right, so let's do 23. Pablo just asked. I'm going to come over here. If you guys could read it to me, I don't have enough room. Okay, what's that?
Could there be possibility like two triangles we have to...
No, not with cosines. In 23, what's A, B, and C?
63.
A is 63. B is 22.
50.
C is 50. Thank you, ma'am. All right, so I'm going to draw my triangle. I have A, I have B, and I have C. So I'm going to say, okay, well, the side across from A is 63, the side across from B is 22, and the side across from C is 50. In this case, guys, what do we not have?
The angles.
We don't have any of the angles. So I got to find all 3 of the angles. I have to find angle A, I have to find angle B, and I have to find angle C. All right, I have to find all 3 of the angles. Now, there was something very specific yesterday in our notes when I told you guys this about finding angles and sides when we use law of cosines. In order to use the law of cosines in the first step, then our shortcut of using law of sines, what do we have to find first?
The biggest side.
The biggest angle, right? Good. So what am I going to find first here? A. How do you know that A is the biggest? Because it's across from the longest side. Good. You have to find the biggest angle first. If you don't, and then you try to use the law of sines in the second step, your angles will be off by a lot, like not just a little bit. So you have to find the biggest angle first. So I'm going to say, okay, that formula would be 63 squared plus equals 50 squared plus 22 squared, or the other way around, 22 squared plus 50, minus 2 times 50 times 22 times the cosine of A, because that's what I'm looking for. Now, guys, in this case, you cannot put all of the numbers in your calculator and just stick it with cosine of A. Because this right here is like saying 2x. If this number here was 25, you couldn't add 25 and 2x and tell me it's 27x. We have an unknown. We have a variable, so we cannot combine multiplication with addition or subtraction. So let's simplify a little bit. What is 63 squared?
3,969.
All right, so 3969, agreed. What's 50 squared plus 22 squared?
3,999.
Yep, what did it say it again?
It's
22, say it again?
Oh, 2,989.
2989? You guys agree? Okay, work through this with us, please, so you know how to do this in your calculator. I got 2984. Yeah? Okay, 2984. 50 squared plus 22 squared? Okay.
Oh, yeah, 94.
Okay, so then I have minus. You have to say 2 times 50 times 22, and you get 2200. So I have 2200 times the cosine of A. All right, cosine of A is what we're trying to get all by itself. It's being multiplied to that 2200. You cannot combine 2984 minus 2200. You can't do it. You have to move the 2984 to the other side. We're going to subtract 2984 from both sides. Minus 2984. So what's 3969 minus 2984? 985, yep. So 985 equals negative 2200 times the cosine of A. What do I do now? Divide both sides by negative 2200. Now, somebody last period is like, you can't do that. I said, why not? And they said, you get a negative number. That's okay. Guys, don't say you can't do that until your calculator tells you, oh, you can't do that. What's 985 divided by negative 2200? I got negative 0.447727. Now, if your calculator tells you error or something like that, then you can stop and say, oh, does not exist. But if I don't want the cosine of A, I want the inverse cosine of A. I want to know what angle A measures. So hit second cosine, second answer. And what do you guys get?
0.0116.
What are y'all getting? 116.597? So we should get, it's about 117 degrees. Angle A is about 117 degrees. So 117 degrees. Angle A is 117 degrees. Now, do we have enough information to say, oh, now we can use the law of sines?
Yes.
Yes, because I have an angle measure. I have the sine of 117 over side 63 equals, what do you want to find?
B.
Okay, you guys want to find B? That's fine. Sine of B over 22. Could we have found C? Yeah, because we know the side length, so that's fine. So we're going to cross multiply. So I have 22 times the sine of 117 equals 63 times the sine of B. Divide both sides by 63. And I get sine of B equals, what's 22 sine 117 divided by 63? 0.31111, I don't want that. I want the inverse of that. I want to know what angle B measures. So second sine, second answer, because we're doing law of sines. And I got about 18 degrees. Okay, that's fine. Angle B, 18 degrees. Now, do I have to do a lot of major calculation now to find angle C? No. What's the only thing I have to do? I have to add the two angles together. So 117 plus 18 gives me 135. And then what's 180 minus 135?
45.
Yes, sir. So angle C is 45 degrees. Lots of work for that problem, but you guys did a great job. Now let's look. Let's compare our answers and make sure we didn't go in the wrong order and make a mistake. The biggest angle should be across from the longest side. So the biggest angle I see is 117. Is that across from 63? Yes. The smallest angle should be across from the smallest side. What is the smallest side? 22, which is across from B. What's angle B? 18. So we're good. That make sense? Yes, sir.
If it isn't,
All right, last thing I want to go over. Actually, that's not true. There's another thing I want to talk about just for a second here. Just say we were given this information. Okay, we're talking about something else now. We're given this information, just the stuff in the triangle. Well, no, I'll leave it like that. We're given this information. And it says, given this triangle right here, what we just found, find the area. Could you do that?
yes.
How do you find the area of an oblique triangle?
We should add them all to that.
No, that's something different.
Use square root.
Nope, that's something different. Nope, that's, you guys, at the one for S right here is only sides. I don't want to, look at this. This is what I'm given. Let's look at it this way. Can I find the area?
Yes. Not yet.
Yes, you can. We did this on your quiz.
Oh wait, I remember.
What would you do?
Once you multiply it, then it's
A times B times the sine of C divided by 2. I would say 50 times 22 times the sine of 117. How come I can do this?
because the angle's in the middle.
Because, yes, I'm given two sides and the angle where? In the middle. You will have one of those on your test again, guys. It's going to say find the area, and it'll tell you that you have two sides and an included angle. That is the formula that you need. Here, we'll do 30 because the numbers are bigger. I don't have a picture, so I'm going to draw one. All right, I have A, B, and C. Across from A is 13, across from B is 9, across from C is 5. If it says area, can I do base times height divided by 2?
No.
No, because I don't have the height. It says area. Do I have two sides and an angle included? No. Could I hypothetically find the angle?
Yes.
Yes, you could use law of cosines and do that. But on your test, it's going to say, using Heron's formula, which I'm going to give to you, which is right here, find the area. So what do we have to find first? We have to find the S value. We have to add up all the sides. So S equals, remember, you have to tell your calculator, hey, add everything first in the numerator, then divide by 2. So when I add 5 plus 13 plus 9, and then divide that by 2, what do I get? So my S value is 13.5. I need to see that part to give you full credit. All right, the next thing I need to see is your formula. I need to see you plug everything in correctly. You need to have your S value first, 13.5. And then what do I do with each side length in S? Subtract. Does it matter if I do 13.5 minus 9 and Pablo does 13.5 minus 5 first? No. Doesn't matter as long as your S value is first minus the side. S value is first minus the side. So 13.5 minus 13. 13.5 minus 5.
It doesn't matter where it goes.
Does not matter as long as 13.5 is first. Now at this point, I would not try and put all of this in your calculator. I would simplify, and I would keep 13.5 here out in front, and then I would say, okay, what's 13.5 minus 9? I get 4.5. 13.5 minus 13 is just 0.5. 13.5 minus 5 is what? 13.5 minus 5 gives me 8.5. All right, now let's do that in our calculator. What's 13.5 times 4.5 times 0.5 times 8.5? 258.1875. Now, some people in my last period did that. They didn't write it down, though. They multiplied on their calculator. Then they hit second x squared, second answer. And if I round that to the nearest whole number, I get about how much? About 16 yards squared, because we're talking about area.
Put the decimal.
Well, it says to the nearest square unit. So guys, every formula that you need is going to be given to you. But you have to know how to use them, how to use your calculator. Just because you have the formula, if you don't know how to input it or how to manipulate it, you're not going to know what to do. So hopefully this is a good kind of summation of everything that we've done. Tomorrow in class, you're going to have a classwork assignment to do that you guys are going to do on your own. If you need super duper need my help, I'll help you. And then I'm going to give you your review so you can start working on that.
Are we gonna get our quizzes back?
tomorrow. Yeah, I have a bunch of people taking makeups this afternoon, so. All right, we're good? All right, thank you guys so much.